All right, so we're starting with by completing the square exact answers. Okay, can we see that okay? Do we need lines thrown out? I don't know. Okay. So really all you need to do is write this x squared minus 12x plus 33. This is a two-parter. They want you to show the first step of what you do, and then they want you to give the solution. How many of you have seen this one and were like, I have no idea what's going on? Yeah, this one is, it's not that hard once you understand it. Before you understand it, you're like, I have no idea what's going on. This one I expected. I'm not surprised to see that we had this one. Okay, so first thing we need to do is we want to make a perfect square. So down here, they're showing us a perfect square means something, x plus something's a number squared. That's what we're trying to create, because once you get in that form, then they become very easy to solve. The weird thing is that's super hard to get it in that form. Okay, so we're gonna, but once you get it there, it's pretty easy. What we do is we're gonna kick out whatever number is right there first. Okay, so I'm gonna move that to the other side, and I'm gonna, hopefully this doesn't bug you, but I'm gonna write up here only because I have a lot of space too, right? So I kick that out to the other side and just make it a negative 33. When you jump the equal sign, a positive becomes a negative. And there's a rule that says I can rewrite this thing as x minus 6 squared. Where did that 6 come from? Okay, it comes from that 12. And what is it in relation to the 12? It's always going to be half. So whatever that number is, I just cut it in half, okay? And I put it in here. And I'm allowed to do that if everything works out. Weird things happen. This is not truly equal, so let me show you what we have to do. I'm going to go off to the side, and I don't really have it off to the side, but I'm going to go up here, and I'm going to write over this stuff. Hopefully, is that awful, Miss H? Okay, so x, that is awful. Basically, I need to figure out what x minus 6 squared equals. Okay, and basically what that is x minus 6 and an x minus 6. That's what that means. And I need to FOIL it. So when I FOIL this, I get x squared minus 6x minus 6x plus 36, or cleaning this up, I get x squared minus 12x plus 36. Okay, does that make sense? So off to the side, I have to figure out what did I just do? Now, would you agree that that's the same as this right here? Are these the same? You should be saying no. What's different about them? 33 is gone. We're ignoring 33. It adds 36. So what I do is I go up here and I go, just kidding, this was plus 36. So I force it to do what I want it to do. Now would you agree they're equal? Am I allowed to just throw a plus 36 on something? Okay? No. I am allowed if I do it to both sides. So what I do is if I sneak one there, I'm going to sneak one there. So now this left side is good, but the right side is going to equal what? 3. Because negative 33 and a positive 36 gives me 3. Okay, so kick out the number. I'm repeating what we just did. Kick out the number, create the perfect square we want, go off to the side and figure out what that perfect square actually is, sneak in this 36 on both sides and clean that up. So down here, they're asking us, which form are you using? Well, you always pick, it's always going to, if this is a minus here, then you're going to use the minus form. Okay? So to answer this question, here we would be clicking on that, and I would put a 6 here, and I would put a 3 there. So this is, right here, this is part of the answer. This is part 1. I don't know if you want to put that on there. Part 2 says, okay, now solve it. So once we have it in this form, it's supposedly easier to solve these. So we say x minus 6. I'm just rewriting it so I have in this space here. First thing I need to do is get rid of the squared. How do I get rid of a squared? It's the opposite of squaring something. That's right, square root, good job. The opposite of squaring is square rooting. Anyone remember we did this a couple weeks ago? What happens when you square root something? That's right, Mason, you get a plus and a minus. Is that what you said? Oh, okay. It's weird because you were right. My video notes will sound better if I'm like, good job, that's right. Maybe I'll get a promotion. So then this just becomes x minus 6. The square root and the square cancel each other out. And we get this ugly plus or minus square root of 3. Now it says to answer, they use the word exact. When they say exact, they mean leave the square roots alone. Okay? If you type in square root of 3, it gives you this ugly long decimal. You can't write down every single decimal. And someone might argue, yeah, I can write all 10 of these. Well, there's more than 10. They just show you 10 on the calculator. So I have to add 6 here. And my final answer is 6 plus or minus square root of 3. But how many solutions? They're going to want us to write that as 2 solutions. They're going to want us to say that the answer is x equals 6 plus square root of 3, x equals 6 minus square root of 3. And that's part 2. That's what we would put as our solutions. Do you want me to do another one? Should I do another one? I don't know. What do you think, Mason? Should I do another one? Yeah. I guess that answer. Okay. Maybe we'll come back to this and I'll do another one. Okay. So the next question we're supposed to do is solving. Can I leave this? Solving problem type 2. We've done this one before, but if you look here, it says that 92% of you haven't done this in ALEKS. So even though we've done this one, I felt like maybe I just needed to do it again. Okay. Also, maybe we need to have the conversation. Do you guys know how to find topics in ALEKS? Anybody not know how to? Okay. So if I asked you to, as soon as we were done here, go do this topic on your Pi, would you know how to find it? Yes or no? Yes, thank you. Someone from this group?
I want them to show us.
Okay. All right. All right. Everybody has. When this. Remind me when we're done with this to one of them everybody has, so we can tell them they have to go do that one. Okay. Anybody remember how we do this? Good. Go with the 1/2. Did I need to make it big again? Okay. Well, you'll write it down and then I'll make it small again, so it gives myself some room. Yeah. Yes, ma'am. Did you get cookies this morning?
No.
Really?
I can't see.
No one got your cookies? They were supposed to, it's from student council. They gave me the, well, they gave me the bits because I didn't mind. Mr. Cruz was like, nobody's getting those. And I'm like, I'll take that. What do I care? Huh. I have to yell at somebody. Oh, we got this? Look how mad she is. She totally cares.
Okay, go ahead.
What's that Justin Timberlake song about the river? All right, so I made that really small to give myself room, but if you remember, it's all about this middle thing. Okay, we go off to the side and we say x to the 1/2 equals blank. We get our answer and we put it into that machine, and then it gives us our next answer. Okay, so and then once I've done that, I rewrite this problem as x squared minus 5x plus 4. I make it into a normal factoring problem. Factor these, right? Pretty sure we factor them. Okay. So you see how I translate? It's called substitution. Instead of that x to the 1/2, I'm just going to put an x there. And then we have to factor this. If you had me or Miss Klein last year, we used x boxes. So it was 4, -5. What numbers multiply to 4 but add to give me -5? You hate this method? Is that what you said? What method do you like? Oh, okay. Got to be able to factor. When you go to college, they're going to expect you to know how to factor. So it's -1, -4. We put that in the box. X squared minus 1x minus 4x plus 4. We get x, -1, -4. Am I going too fast? Sorry.
Really?
Need some honey for my throat.
You're like a child.
I am like a child. You know what my wife said to me maybe 20 times this weekend? Act your age, not your shoe size. And halftime in soccer games for kids soccer games.
You were like the rodeo clown?
No.
Oh.
But are you allowed to go out on the field and kick the ball around?
Probably not.
Well, according to my wife, you're right. I said, people do it all the time. She says, kids do it. Kids. They're 40.
You just out there by yourself?
No, I'm kicking with kicking with my daughter. Anyways. All right, so we rewrite this as x minus 1 times x minus 4 equals 0. So what makes that equal to 0 is a positive 1 and a positive 4. A lot of people would have done all that work and gone, oh, there's the answers, 1 and 4. You would be incorrect because now we got to put it in the machine. The machine says take whatever answer you have and put it right here. So 1, how do you get rid of a raised to the 1/2? That's great. You square it. Good. So to get rid of raising to 1/2, we're going to square this thing. 1 squared is 1. So our real answer is 1. And then I got to put 4 in the machine. And some of you can just see that if I put a 4 in that machine, it's going to give me 16. So those are my real answers. That green is like invisible green, isn't it? Can you see it at all?
Yes.
Oh.
No, I'm not.
You're not going to miss me?
No, not at all.
You're gonna miss me when you're gone. Shooby-dooby-dooby-doo. We good on this one? So I'm not going to do the next problem, but if the next problem were to pop up, look, it just changed. My circle ended up being in the same spot, and I would just do all the work I did, but this would be a 1/3. And how would you get rid of a 1/3?
What?
We got rid of a 1/2 by squaring it. A 1/3 we're going to do. Thank you.
I already answered the last question.
I know.
I
You.
answered the last question. Who said it? Me. I answered.
Domain and range. So for this one, what you're going to want to write down is that we have a parabola. And they basically give us 1 point. They tell us the vertex, and this is all you got to do, is that point right there is 0, -1. Don't you feel like when someone says something like, I'm not going to miss him, that they're really saying, I'm going to miss this.
No, that's
This
not
is
what
one of
I'm
the,
thinking of.
this is one of the things you'll look back on and go, you know what, that was actually kind of fun.
Going through my head.
Ah. So I like to take graphs, physical graphs, and we have to mentally put a box around this, and you can do this on your paper. But let's go ahead and put the smallest box possible on this graph. I think we've done this before in here, haven't we? On one of the other ones. I kind of remember doing the box. And here's the thing about the box. Which walls is the graph going to break? There's a top, a bottom, a left, and a right. Which one's it going to break? Definitely the top. Okay. So what I like to do there, if it's going to break, that means it's an infinity. Okay. Where else is it going to break? The sides. It's not super clear, but this thing is slowly going to be pushing out. Okay. So it'll break the sides. So they're infinities as well. Now here's the thing. Which one of these is a negative infinity? Which one's the negative? Were you paying attention, Mr. H? Yeah. Which is the negative infinity? She pointed that one. Actually, she went like this. Oh, my wrist. I broke my wrist. Okay. That's a negative. There are two numbers on the bottom. What is actually that number? -4. Is that what you said? -4? You should start feeding her bogus answers. I like that. This is actually the -1, okay? Because that's how low that is. 0 is telling you how far left and right it is. We want to know how low it is. I just found the domain and range. Domain is right here, okay? And domain is always, seriously, look at that. Huh? Oh. How bizarre. Isn't there a horn in that? So this is our domain. And this is, the other one is our range. Okay. And they want it in interval notation, am I right? Does it say that? Okay. So it would say domain, and we would say from -infinity, oh, 5.0, to infinity and beyond. And my range would be from -1 to infinity. I made this mistake last week, I think, that -1 would be a bracket. Shoo-ba-doo-ba-doo-ba-doo. Goodish. I'm curious what the next one looks like. We don't have to do it. I think they're all parabolas. Okay, so then we would just draw the box here. Okay, and really, the only number that's going to really matter is this one right here. If they're all parabolas, it's going to break out the sides no matter what. It's going to break out the top. Unless it's flipped down, then it's breaking out the bottom. Easy peasy strawberry lemonade. This one, classifying the graph of a function. Bless you. So all of these are going to basically look the same. You see that? It's the one we just did, isn't it, Lindsay? Yeah. Yeah, I'm glad we just, yeah, I do. So it's multiple choice, and the choices are, yeah. You know what? I think I got this, Ms. H. Do you want to do notes next Monday?
Yep.
Okay. Why are you?
Because I like her.
You're going to miss her?
Yeah, just not you.
So what it asks for is whether it's linear, parabola, horizontal line, vertical line, positive slope, positive parabola, negative parabola. Okay. So Miss H has got a point. We could just graph these if we wanted to. On that first one, what is it? Do you need me to make it larger again? It's linear. How do we know it's linear? First of all, how do you know if it's not linear? They're either going to be linear or not linear. What's not linear up there? Why is the second one not linear? Good. Because the x squared makes this not linear. So this is the parabola. Okay? And they're going to ask you, is it going up or down? Well, we can tell because the x squared, if the x squared is positive, so here's a little note, a positive means up and a negative means down on the x squared. So positive, I guess I need to put that, positive x squared, negative x squared. So on this particular one, what is it? It's up. So it doesn't matter that this is a negative here. All that matters is that's a positive, so this is a parabola, up. Thank you. The first one is so the other ones are linear. And the question is it a positive or a negative slope? Positive slope or negative slope, and how can you tell if the x is negative? So it's basically asking you what's going on with the x. So the answer is that it's linear with a negative slope. When you write in this notation, what does g of x actually mean? We learned a lot, Miss H. So all of these really is another way of writing y, okay? So really that third one is y equals 4. When it's just a number, when it's y equals any number, that is a horizontal line. Anyone want to guess how to make a vertical line? Good. A vertical line is when it says x equals some number. Don't be confused. G of x actually means y. Okay? If it was just x by itself. So on this last one, we would say that it is a horizontal line. I think they kind of expect you to do it without graphing them, but if you want to graph them to see what it's doing, that's fine. Okay. Did we get that? I think we do. Number 30. This one is by special request. This is the one that most of us have available to us. So this is the one I want us to look for when we're done. Say again? Yeah. We talk, you know, there are always problems, and it's not necessarily a hard one, but there's always problems that almost everyone gets confused by when they do it in ALEKS. Do we need to make that bigger? And this is one of those confusing ones. Get it written down, Brandon? Is that the truth? Okay, I want you to write it down then. So if you look at the three on the bottom, tell me what's different about those three things on the bottom. Say again? Okay, so they're all different signs. So it might be a plus, a minus, or a multiplication. Brought me money? Thank you.
And I need attendance for first and second.
Second, oh.
For first and second.
Wow. Thank you. Okay, so yeah, so plus, minus, multiplication. What's different? Also different about them? Good. So just so we know, if this right here is an X, that means we're ending with an X. If this is a number, that means we're ending with a number. What this is saying is plug in that number and then do this. What this is saying is plug in X and then do this. Well, there are already X's, so you don't have to actually plug in X. If I wanted to be weird or goofy or different, I could make this an A here, and that would mean plug in A and then do this. All that would do is change the variable. They didn't do that. So we kind of approached the third one very differently when we approached the first two. First one says, take S, whatever it is, and minus T from it. So I just say 2X minus 6 minus, in parentheses, X plus 1. That is taking S and subtracting T from it. Now, that's not the answer they're looking for. They want us to clean that up, but that's my first step. I could distribute in this negative. Okay, so really I have 2x minus 6 minus x minus 1. I just distribute in that negative. And then combine like terms, I get 1x and minus 7. So literally all I did was take the s and I subtracted the t from it. The next one's exactly the same, except instead of subtracting, we're adding. So it says take s and add the other one to it. I don't have to distribute in a negative here, so we end up with 3x minus 5. Now, if there was another one, I'm going to add one on here. If there was one that said S times T X, and we don't need to do this to do the third one, but if there was that was the case, then I would have to take this times this, 2x minus 6. And this might be a curveball they throw at you, x plus 1, and then we'd have to FOIL that out. Can't remember. Sometimes they let you just put it like that and not FOIL it. Do you remember, Mason? Okay. So sometimes you get away with it, sometimes you don't, but that's what that means, is just take those two things and multiply them out. So we would FOIL this. We would have 2x squared plus 2x minus 6x minus 6, which equals 2x squared or minus 4x minus 6. Okay. And personally, I think the easiest one is when they do give you a number. All I'm going to do is I'm going to plug 1 into the top one, plug 1 into the bottom one, and then it says multiply whatever answer you get. Okay. So what happens when I'm going to go off to the side for this? What happens when I plug in 1 here? So 2 times 1 minus 6. 2 times 1 is 2 minus 6 is minus 4. And what happens when I plug in 1 here? 1 plus 1 equals 2. And then it says multiply that. Negative 4 times 2 equals negative 8. I think some people get confused because they see the number and the x and they don't know. All of a sudden you get numbers with x's and numbers with, or answers with numbers when you shouldn't. You have them backwards. But like I said when we started, if you have an x here, we end with x. If you have a number here, you end up with just a number. Okay? These peas of strawberry lemonade. I don't know. I'll think about it here.
There's a whole bunch that were out for that.
Okay. I'll think about it when I'll do it in a second. Thank you though. I appreciate it. Any questions on that? We would like you to find one of these topics and show us that you can, and then actually knock it out of your pie. Once you do that, then we'll give you your 10 points for your writing your notes. Okay? Actually, just showing us that you can find that topic will give you your 10 points for notes, plus showing us your notes, which I assume you all do. Okay.